So now we're going to look at wave interactions investigation. So we got a link to the assignment, a link to the simulation, and then a video that kind of goes over this stuff. If you didn't get enough info from the doing the vocabulary, you can watch this video, and he kind of goes over the stuff that we're looking at, how waves interact, right? So you got waves coming in all these different directions. They hit each other. They bounce off of stuff like echoes. They interact with each other, right? Here he's showing interference patterns, how, you get two waves, they can make a bigger wave, right? Or they can cancel each other out in destructive interference. So waves are additive, right? They can be positive and negative. They hit each other. They could add together or subtract. And so there's a bunch of different things like this. This is diffraction, right? So this wave is coming through a hole, kind of like the way we can hear stuff going on outside a door, right? People are talking out there, or you hear a siren or something, the waves come through any type of opening, and then they spread out and you could hear everything, right? All right, so anyway. So here's the assignment. So let's take a look at it, and I'll show you the So it says waves interact with matter in 4 fundamental ways: reflection, refraction, diffraction, and absorption. This simulation allows you to see how each of these interactions affects waves of different frequency and wavelength. So it says part 1, investigate reflection. All right, so I'll do part 1 with you. Press run to watch the waves propagate. Change the wavelength and our frequency and press run to see the new simulation. Repeat the simulation for 3 different boundaries or reflecting surfaces. Okay, so you're supposed to do an angled wall, a concave wall, and a convex wall. Press run to watch each new simulation. Sketch a continuous plane wave reflecting from a straight wall. How does the direction of the wave change? And then B, sketch a continuous plane wave reflecting from an angled wall. Okay, and then we got concave, convex. Okay, so let's do the first one. Sketch a continuous plane wave reflecting from a straight wall. Okay, so we're going to draw reflection. How does the direction of the wave change? Okay, so let's look at this. So you're going to have to make a copy. And simulator. And you click on this little thing right here. All right, so we're going to look at, it said reflection, right? Reflection, continuous, and we're going to do a flat wall. All right, so let's run it. So we see our waves coming in. So the white and the black. So the lighter color here on the waves are this is like a top-down view, right? So the lighter shades of blue are coming up, and the darker parts are down. So it actually looks like a wave, right? But from top down, you see this kind of pattern. I thought there was, let's see. Very flat. All right, so what's going to happen? So it's hitting the boundary, and then look, now it's coming to the left, and the tone of the colors change, right? They got darker. Let's redo it. It's the same thing. So see how they're kind of light here, but then when they start reflecting back on each other, they get lighter and darker. And that's what we were just talking about the constructive interference. The higher points got higher and the lower points got lower. So, and what do we notice about the direction? It changed direction, right? So waves reflect off of objects. So a straight flat wall, they just come straight back, right? So how would we draw that? Let's see. This might be a delete. Sketch a continuous plane wave reflecting from. Okay, so we're gonna do an insert drawing, and then here you can play with scribble. Actually, I might like whiteboard fox better to draw. So let's see. Let's try to draw something there. Basic, extra. Can't change the thickness. Basic. All right, so we got our tank. We got the wall. Right, and then so I'm going to say the waves go this way, and then they come back, right? And what did it look like? Well, we had basically stripes, right? And then how did it look? So dark, light, dark, light. So then I would just do something like that. So for this one, then you say, take a snapshot of that, copy image, and then you could just throw it into your here thing here. And you can make it a lot smaller. And then you could write a little bit. Sketchy, a continuous plane wave reflecting from straight. How does the direction of the wave change? Once the wave hits the wall, it is reflected back. What would you say? How many degrees is that? Like 180 degrees? Something like that. And that's it. So you can sketch what's happening, talk about it a little bit. Sketch a continuous plane wave reflecting from an angled wall. Okay, let's do an angled wall. Let's see what that looks like. So let's do the boundary, an angled wall, and here's the concave and convex. So an angled wall. So let's run this. So you can see they start reflecting this way. And it makes this interesting pattern. So you would, I mean, really, you could even just, I'd rather you draw it, but you could do this too. Be like, oh, let's just take a snapshot of that. Copy, and then you could talk about it. So then you say like, once the waves hit the angled wall, and then you could finish. I'll let you finish that. So different ways to do it. The next thing I'm going to do says investigate refraction, diffraction, and interference. Investigate refraction of plane waves for two cases, a flat boundary and an angled boundary. Investigate diffraction of plane waves for three cases, around a half wall and through a flat wall with single and double gaps in its middle. Okay. So let's look at refraction of plane waves for a flat boundary and an angle. Okay, let's look at refraction. So now we're going to change this thing. Let's see, waveform. So we're going to look at refraction, which changes the thing. And did it say a flat wall? Investigate refraction of plane waves for two cases, a flat boundary and an angle boundary. Okay, so flat boundary and angle boundary. So we've got refraction here. So this is where you're gonna, where it tells you like what type of behavior are you looking for. So right now we're doing refraction and flat. Okay, let's run this. Oh, so what's happening? So there's some type of boundary here. Here the waves are coming, and then they go through this boundary, and look, the wavelength got smaller, right? So the wavelength got smaller. You could draw that. So this is refraction. So maybe, so you should know what refraction is by this point, right? But that's okay. See, refraction means your wave gets bent or it changes direction a little bit, and that's this is the phenomenon of color, right? Going through a prism, or when you look at a straw in a glass and it looks disjointed because the waves are changing, right? That's kind of what this is showing. Because we talked about that, how everything's a wave, so vision is a wave. So these light waves are coming at you, but if they go through different substances, it changes the speed or it changes the direction of the wave. And that's why, like, if you've ever looked at like things underwater, you can't actually hit them. You have to like account for refraction because where things look like they are, they really aren't because the waves are going through water. So that's refraction. And this is the type of stuff you're supposed to do with the vocabulary. And let's look at the angled wall. What happens then? Angled. So you have the waves coming, they hit an angled wall, like they're changing the direction and speed. Wave interaction, plane, circular. But yeah, that's it.